Hello everyone, good morning and welcome back to KCS online platform. Hope you all are doing well and we are discussing about the equations of motion. We have discussed three fundamental equations: u equals to p equals to u plus at and s equals to ut plus half at square, then v square equals to u square plus 2s. Apart from this, in last class we have discussed about one more important equation, that is the distance travelled by an object in the nth second. Sn equals to u plus a by 2m minus 1. So we have solved the problems also on that one, and whatever the equations so far we have discussed, those all are for what? Those all are for horizontal motion. Then you may ask, what will be the equations of motion? How we can find the final velocity? How we can find the time taken? How we can find the height attained by the object? Suppose instead of it is not moving in the horizontal, instead it is moving in the vertical direction. Suppose a ball is thrown, how I can guess up to what height it will reach? If suppose a ball is thrown, when it will come back to the ground, how much time it will take to go up and the highest peak of the its point of attainment, then it will come back. So total how much time it will take, all those things. So we cannot, it is not possible to use these equations, but we can modify the same equations, and we can calculate whatever we want for the vertical motions. Okay, so that is what when the object is in vertical motion, we call it as what? Motion under the gravity. So these equations will convert into what? The equations for motion under gravity. Okay, so today we will discuss about the equations of motion or kinematic equations for a body in vertical motion, or the motion under the gravity. Okay, so in the horizontal motion we have 3-4 equations. I will take only 3 fundamental equations. V equals to u plus at, where a is the acceleration, u is initial velocity, v is final velocity, t is time. S equals to ud plus half at square, then v square equals to u square plus 2es. Okay, so these are the fundamental equations which help us to find the describe the motion of the object when it is along the horizontal. Okay, so now instead of this one, if object is moving either upward or downward, okay, then what will happen? What are the things changes in these equations? Okay, the first thing, velocity will not change. So whatever with velocity you are throwing, velocity you can take it as u only, so that is not a problem. So velocity you can take it as u, final velocity you can take it as v only. If you are throwing here, final velocity will come to this point. Then time though you can take it as t only. Only thing changes is, so the instead of the horizontal distance s, you can take it here as a height h. Okay, so then apart from this one, what else will change? Acceleration. This is what very important. Acceleration will become what? Will become the acceleration due to gravity. You all know that value constant for the near the earth surface. If you go beyond, it will change. So you can take approximately symbol only I will take. So in place of a we have to take z, but the sign of g is very important, whether we have to take positive or negative. It all depends on whether body is moving in upward direction or downward direction. Okay, so we'll have the discussion about the sign conventions. What are the signs we have to consider, whether you have to take displacement positive or negative, because if body is moving, height will be what? Above the initial position. If body is coming downward, then the final position will be what? Below. The height will be what? Below the initial position. Then when we have to take positive, when we have to take negative. And what about the value of g? Acceleration due to gravity. Suppose body is moving upward, g is what? In downward direction. Opposite. Okay. If body is also moving downward, then g is what? It is also in the downward direction, because g is what? Always towards the center of earth. So its direction will not change. Because of the direction of body changes, we have to change the what? Sign of acceleration due to gravity. Okay, so then what are those sign conditions? Suppose your body is here. This is what initial position, position. We can write it as initial position here. Okay. So suppose if you throw here, so this is what this become final position. Or if you throw in downward direction, this will become what? This will become final position. Okay. In this case, height will be here. This is going to be your height. Okay. In this case, height will be here. Okay. Now, when we have to take positive, when we have to take negative. Suppose if this is your initial position, the first point is that. First point is that. What is that one? What about the height? Or you can take velocity. What about the velocity? When we have to take velocity positive and when we have to take velocity negative. Say, very simple, if body is moving upward, then you take velocity as negative. Okay? Sorry, positive. So suppose if it is moving downward, you take velocity negative. It is very simple. If body is moving upward, velocity will be positive. If body is moving downward, velocity will be negative. That's all. So second conclusion is about the height. That is what displacement. Displacement. You can take it as height. Okay. So here, what you have to do is, if final position is above the initial position, this is what your initial position. If final position is above the initial position, then h is taken to be what? H is taken to be positive. Instead of that one, if final position is below, then h is taken to be what? H is taken to be negative. This is what initial position. So this h will become what? This h will become positive. This h will become what? Negative. Okay. Here, if you are moving here, you will become what? You will become positive. If you throw in this direction, you will become what? Negative. That's all. So this is what the second. Very important is third point. So what about the acceleration? What about the acceleration? So what about A? A is equals to what? A is equals to Z. We can take it as equals to Z. Then what about this sign? Positive or negative? One thing is, we can change sign also, or we can fix the value or the sign of G as a or what we can take it as for the whole study, either positive or negative, like that. So okay. So better we'll go with what? G you take always negative. If you take G always negative, so what will happen if you take G always negative? So this will become A equals to minus G. A equals to minus G. So based on these sign conventions, these three sign conventions, so these are the what very important sign conventions. Okay. Or without sign conventions also we can solve that method also, I will tell you. So before that one, we will go as usual. So these are the what sign conventions we have to remember. By taking these things under considerations, we have to write these equations. We have to write these equations according to the sign conventions what they have given here. Okay. So let me take this example when body is moving in upward direction. So what will be the equations? Okay. Suppose body is moving in upward direction. So upward motion. If I take body moving in upward motion, so this is the ground, here it is body, so it is moving in this direction. Okay. So what you have to do? You have to take h. Okay. So this is what initial velocity u. So height you have to take positive or negative. It is above the water. It is above you can take. This is what, if it is above and below you can take here. You can write above the initial position, and here it is below the initial position. Okay. So if it is above the initial position, So what you have to write? H you have to take negative. H means displacement. Yes, you can write. That's okay. Displacement S equals to minus H. Velocity U equals to what? It is in upward direction, so positive U. G as usual, acceleration as usual, what? Minus G. So we'll see that how the equations will get changed. So what is the first equation? First equation is V equals to U plus AT. So now apply this one. V, write as it is, U positive plus A is what? Minus G. T to no need to change. So equation will become V equals to U minus Z. Okay. This is what first equation. For upward motion, first equation is V equals to U minus G. Second equation. Second equation is S equals to UT plus half AT square AT. Okay. So what is the H? S is going to be minus H because minus or plus. Sorry, extremely sorry. It is plus H. Okay, not minus because above it is. See, for above it is going to be positive. Okay. So now S equals to plus H. H equals to U. T write as it is plus half. A will be minus G T square. Now H equals to UT minus half GT square. UT minus half GT square. So this is what going to be our second equation. So third equation is what? Third equation is V square equals to U square plus 2AS. So V is positive, U is positive, 2 minus G, S will become positive H. So V square equals to U square minus 2GH. Okay. So these are the three equations for upward motion. Okay. So equation got changed. Okay. So for vertical motion, the equations got changed. In place of positive, negative T, and in place of a G. Okay. So that is what for upward motion. So let us see for the downward motion. What will be the equations for the downward motion? Okay. So for downward motion, what will happen? The object is going to be here at some height, and it will be thrown in downward direction. It is already there at some height. Okay. So now the U is what? U is in downward direction. So U is going to be what? Negative or positive? There it was positive, here it is negative because it is in downward direction. Then what about the H or displacement? S equals to, again your final position is below the initial position. What rule is saying? Below, if it is below the initial, the final position is below the initial position. So what will happen? Your H is also going to be what? H is also going to be negative. So we can take it as what? We can take it as minus H. This we can take it as minus U. So similarly, one more thing, A, as we mentioned in our sign convention, A is always what? Minus G. Okay. If this is the case, we will check for the first equation. First equation, what is that? V equals to U plus AT. So let me take over here. First equation, V equals to U plus AT. P is what? Negative or positive? Velocity, final velocity. All velocities you have to take what? Negative. So P is also what? Negative of P. Minus V equals to minus U plus minus G into T. That means minus V equals to minus U minus GT. All negative you remove, it will become what? V equals to U plus GT. This is what your first equation. Okay. So there U minus GT, here it is U plus GT. Second equation, S equals to UT plus half AT square. S is what? Minus H minus UT plus half minus GT square. So minus H equals to minus UT minus half GT square. So all negative you can remove, it will become what? H equals to UT plus half GT square. This is what going to be our second equation. Okay. So again, there it was h equals to ut minus half gt square, here it is h equals to ut plus half gt square for downward motion, for downward. Okay. So third equation is v square equals to u square plus 2as. V square minus v the square will become plus only, minus u the square will become plus only, 2 it is minus g, it is minus h minus g. So this will become plus v square plus u square minus again plus, that is 2gh. This is what will be the third equation. Their third equation was v square equals to u square minus 2gh. Here third equation is v square equals to u square plus 2gh. Okay. So these are the equations of motion for downward motion. Those are the equations of motion for upward motion. Okay. So this is how we can convert our horizontal motion kinematic equations into the motion under gravity equations. Okay. So totally we got 6 equations for upward motion. So what we got P equals to u minus gt for upward motion I'm talking. So then h equals to ut minus half gt square, and v square equals to u square minus 2gh. Okay. So these are the equations for upward motion, because these downward body is moving in upward direction. So next, for downward motion, so what are the equations we got? We got P equals to u plus gt, h equals to ut plus half gt square, then v square equals to u square plus 2gh. Okay. So these are the equations for downward motion, upward motion. How these equations came, we already know. We have taken all the sign conventions. Whenever what is the v, whether positive or negative upward, u is what, u is positive, v is positive for downward, u is negative, v is negative for upward. S is what, plus h for downward, s is going to be what, minus h for upward also, for downward also, g is negative. Okay. Those are the sign conventions. From that these equations came. Then you may ask me, so why to remember all those sign conventions we don't want? So we can easily we can remember, or we can frame these equations by changing the acceleration due to gravity sign. Usually g we take fixed. Okay, that is what the rule we have followed, and we got equations also. So we don't want to change the sign conventions of velocity and the height. Then how we can remember these equations? Very simple. If you don't want to change the signs of velocity and displacement, better you change the sign of acceleration due to gravity. If you do so, what we have to do is very simple. If body is moving upward direction, g is what? G is downward. Okay. So g is downward, body is moving upward. If this is the case, both are what, opposite. So you take it as it is. Acceleration, it is downward, opposite to this one. So you take it as what? You take it as minus g. Only consider this much. You will get what? You will get equations. What is that? V equals to u plus a. Okay, what is it? Minus g. So equation become what? P equals to u minus gt. Oh yeah, what is that? S equals to ut plus half at square. So S equals to what? H. Don't take sign conventions of what? Here you have them. So H equals to what you can say? Ut. A will become what? Minus. So minus half gt square. V square equals to u square plus 2gh. So you can take it as v square equal to u square minus 2gh. This is just for what remember purpose. Without doing all those things, without confusing, we can directly remember the equations. Same equations you are getting for upward. Okay. Just by changing what? By changing the g negative we are taking. Okay. So if it is moving downward, if it is moving downward. So here both are in same direction. U is also in direction, G is also in downward, because G is to always downward only, means towards the center of earth only. So now here we have to take G as positive. So U take as it is. So A you take it as plus G. So your equations will become V equals to U plus AP will become V equals to U plus G. What is that? S equals to UT plus half AT square will become H equals to what is that? UT plus half GT square. You have to take just G positive. Don't worry about all displacement and other things. Just for review purpose I am telling you. So V square equals to U square plus 2AS will become what? V square equals to U square plus 2GH. So same equations you got, whatever you got for the downward motion. Okay. So that is what how we can remember. That is what, if body is moving upward, G is downward. Both are opposite. Take G as negative. If body is moving downward, G existing due to gravity is also downward. Take it as what? Positive, because both are in the same direction. So you will get again same set of equations. This is what for the remembering or writing directly the equations of motion for vertical. Okay, but when you solve the problem for something, better if you consider all 5 conventions. But finally what you will get is again you will get same equations only. Okay, even though you take V and U negative, again negative will remove, it will become what? It will become positive only. So I hope this will help to write the equations directly. So let me take an example where you can use these equations. Suppose you are going for playing cricket. First thing is we'll toss the coin. Okay. So suppose if you toss the coin, so say if you throw with some velocity, say 5 meters per second. Okay. If you are thrown with some 5 meters per second, so what will happen? So it will be some height, and again if you drop, again it will return. Okay. So how much time it will take to return those things will go later. As of now, how much height it will reach? Okay. So we can say how high does coin will go. Okay. How high? How much high we can say? How much high does coin go above the ground? Okay, means above the initial point. So we can say above the initial point. We can say initial point. Ground in the sense again from this point there is some height ground also. So if this is the case, what you have to find? You have to find this height. Means it will go and return. Okay. So this height you have to find. This height we have to find. To find this height, we have 3 equations. V equals to U plus AP, S equals to U square plus 2, AS, and third equation is P square equals to U square plus 2, AS or GS, whatever. So how to select that one? T we don't know. So in first 2 equations, T is there. So don't this will not be used for us. So third equation, T is not there. What is there? U is there. We know U. G is also, H we have to find. V. Do you know that what is the value of V? So initial position, U equals to 5 meter per second. H, so H is we have to find. Then what about the G value? G is approximately instead of 9.10, I will take 10 meter per second, approximately second square, approximately. What about this point? Final velocity. Final velocity is going to be 0 because coin will go with some speed, then it comes to rest, then come back. It is going to rest means what? V is going to be 0. So V is going to be 0. For upward motion, these are the equations. Okay. So which equation we can use? We can use this equation. So what you can write? You can write as V square equals to U square minus 2GH. Okay. V square is 0. U square means 5 square. So 5 square minus 2, this is 10 and h. Okay, so take 20h on this side, this will become 25, so h equals to 25 by 20, so h equals to what? H equals to 5 by 4, so this is what, this is going to be 5 by 4 meter. Okay, or you can say h equals to say 1.25 meter. So this is how we can find how much height it will reach, or maximum height reached by the coin. Question they will change. This is what maximum height also we can find. Okay, so maximum height reached by the coin. Maximum height in the sense at that point its velocity means final velocity is going to be what? 0. Or they may ask one more question, what is that? How much time it will take to reach the maximum height? How much time it will take to reach the maximum height? Time they may ask to come from here to here. How much time will it take? Okay. So for that, which equation you can use? You can use the equation P equals to U minus GT directly. So you know V is 0, you know U 5 minus G is water 10, T is what T is, you have to find. So 10 T equals to what? 5, so T equals to 5 by 10, so T equals to 1 by 2, so T equals to 0.5 seconds. In 0.5 seconds it will reach the maximum height, again it will come. So it is not time, that 0.5 is not a time to go and come, it is only for to reach maximum height. Again you have to find how much time it will take to come back. So that is a different concept. Both times are going to be equal. Again we will prove that. But this is what is simple equation to where you can apply your motion under gravity equations. Okay. So one more exactly similar example I will take, but we will conclude something. We will get one wonderful result over here. Suppose something is thrown from here. Suppose something is thrown from here, so it will go and reach some height, then it will come. Okay. So you have thrown it with a velocity say u equals to 5 meter per second. So it will reach a maximum height and it will come. First thing is we will find what is the height reached. Okay. So how much height it will go, this we will find first. Okay. So obviously in last example only we have just solved this one. So what is that one? To find that v square equals to, for upward motion, u square minus 2gh. Okay. V is at the extreme position it is 0, at the pinnacle it is 0. So 0 equals to u square means 5 square is 25 minus 2. So g is what? G you can take approximately 10. So h equals to what? H equals to 25 by 20. That is what? 5 by 4 meter. Okay. This is what the height. Now what we'll do is, what is the time taken to go there? So time taken to reach maximum height is time taken for upward motion, t for upward. So what is that? V equals to u minus g you have taken 0, u is 5 minus 10 into t. So t is what? T is 1 by 2 seconds. Okay. Similarly, we will check what is t for downward. How much time it will take to come from here to here? We will find this is what t2 equal. While going for how much time it has taken? It has taken t1. T1 is what? 1 by 2 seconds. How much time it will take to come to the again ground? Here, this final velocity will become what now? This will become initial velocity. Okay. So h, you know, h is what? H is 5 by 2. Apply the formula s equals to ut minus half g square. Yes, what is this? S is 5 by 4. U is what? U is going to be 0 now. Okay. Forget about this part. For second part here, initial position will become what? Initial velocity will become 0. Final may be anything. So this is 0 into t minus half 10 into t square. Okay. So this is 1. 5 by 4 equals to, this is what? 5 into t square. 4 to 5. Okay. So negative will be there. So now this is for downward motion. This is for downward motion. So equation will be what? Equation should be positive. So what will happen? 5 will also get cancelled. T square equals to 1 by 4. T equals to means root of 1 by 4 will become what? 1 by 2 second. So your T2 also 1 by 2 second. For T1 was also 1 by 2 second. T2 is also what? 1 by 2 second. That means time taken for upward is equals to what? Time taken for downward. Means time of ascent is always equals to time of descent. Time of ascent is always equals to time of descent. How much time it take to reach maximum height? Same time it will take to come back to the ground. So if they ask total time of the tossing the coin, total time will become what? Total time will become time of ascent plus time of descent. So total is what? 0.5 second plus 0.5 second will become 1 second. This is how we can calculate total time. So no need to calculate this to every time. If we calculate one, understood that the time for downward is also equal, or it is same as the upward motion. Okay. So downward and upward, the time taken is always what? Is always equal. So remember this point. This will help you solving the many numericals. Okay. So we'll conclude one more thing here. What is the velocity here? Means the velocity at the initial position when it go and come. What will be velocity at that point? Means the final point, but it is what? It is same as the initial point from where it has started. Okay. So if you look at that one, so at the upper point, u was what? U is 0. P you have to calculate. H is what? H is 5 by 4. So it is what? Downward motion. So can I apply this formula? Which formula we can apply? We can apply v square equals to, or simply you can directly apply phi equals to u plus gt. Phi is what? You have to calculate. U is 0. G is g 10. Time taken only to come from here to here is what? 1 by 2 seconds. Okay, so v equals to, get cancelled. So 5 meter per second. What is the result? At the same horizontal line, while going, what is the velocity you are given? When it comes there, the same velocity, u equals to v. Get it? With what velocity you are throwing? With same velocity it will reach the what? Ground. That means, suppose you are throwing from here. Suppose you are throwing from here. If you throw from 10 meter per second here, when it comes at this point, again its velocity is what? 10 meter per second only. This is the very important result to remember. About the one thing is velocity, and another thing is the time of ascent equals to time of descent. Okay.